Hey guys, Mr. Kyle, Myers Mathematics, and let's just jump right into it. This is the second half of adding and subtracting rational expressions. So, jumping right back in where we left off at number 15. If you haven't seen the first half, go check out that first because I go a little bit slower at the beginning talking about some of the things that I'm going to do right now. But basically, this first one here, the two denominators, n plus 1 and n minus 7, don't have any common factors. So the fastest way is to do what I usually just call crisscross applesauce. It's not cross multiplying, so I had to come up with a different name for it. So what we do is we do bottom right times top left, so 7n times n minus 7. Okay. Keep the sign that's normally in the middle, which was a plus. And then bottom left times top right. Okay. And it's just a little bit laggy today, so if you notice a little bit of lag, that's what that is. n plus 1 and n minus 7. Okay. So we are technically done with the combining of the two fractions, but the point of this is to simplify. So let's see if we can simplify. We want to combine like terms. So it's going to be 7n squared right here. This is 7n squared minus 49n. And over here we have plus 8n plus 8. So if we combine all of those, we would get 7n squared and then minus 41n, because 49 would be subtracted into the 8, and we get minus 41. Minus 41n plus 8. And I don't think those can factor, at least not into things that might turn into something else, like an n plus 1 or an n minus 7. So since that doesn't seem to be the case, we would pretty much just call it a day at that point. So box it all in and move on to the next one. Same thing with number 16, so crisscross applesauce. This time we're going to go a little faster. We're going to go ahead and distribute the 2. So this would be 2n plus 2 plus 4n plus 32, almost at 36, over n plus 8 and n plus 1. All right, then if we add up the top stuff, we get 6n plus 34. And that factors out a little bit, but not by much, so that's not really going to matter if we factor that even more there, because it's not going to turn into an n plus 8 or an n minus 1. Sorry, n plus 1. Because it doesn't, we're done. The whole point of trying to put the fractions together is so that we can get the box, something to cancel. We want to cancel things. When you cancel things, it normally makes it so that your fraction is smaller. That's why we're combining the fractions at all in the first place. We might get something to cancel if we can combine. But if nothing combines, there's no point in trying to refactor, even a little bit. All right, moving on. So we would have, we're going to distribute again. So again, 8, 3x plus 4, the two denominators don't have anything in common, so we do crisscross applesauce. This time I'm not going to write it because I don't want to cross out that minus. That minus is the sign in between them. Bottom right times top left, I'm going to do 9x plus 12. I keep the sign in the middle, so it'll be 3 times 8, but I'm going to have a minus. 3 times 8 is 24. Over 8 times 3x plus 4. And let's see if that simplifies a little bit. It looks like it will. 9x minus 12 over 8, 3x plus 4. So if I factor out a 3, I would get 3x minus 4 left over. But that's not going to cancel with 3x plus 4. So actually we're done. It seems like that might turn into something, but it really doesn't. It almost does, but we can't have almost. Almost only works with horseshoes and hand grenades. this is neither of those things. So we move on to the next one. And again, with the same denominators, right? The same situation with the denominators, I should say, because the denominators do not have anything in common. So crisscross applesauce once again. 3b plus 9. And sorry, it's being a little bit glitchy. I'll have to. It might be because I downloaded some stuff right before shooting this video, and it's not done downloading or something, and maybe that's why it's a little glitchy. Got some free CAD software. I'll let you know how it goes. If it's any good. B minus 8, B plus 3. And then we would combine those as best as we can. 3b and 7b make 10b, and 9 and 56. So that's going to be, what, 47? Yeah? So 10b minus 47. Okay. Well, that's not going to turn into anything either. So we're done. Again. Again, 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 again. Same tune, different problem. All right, on to the next set. We bled over a little bit into 19 here, and 20. But you know what? That's what these little bars are for right here. Make a little dividing line there. All right, again with the denominators, they're different, so we just crisscross applesauce. That's going to be 3x minus 6 plus 7x plus 42. And let's go ahead and combine those. That's going to be 10x, and that's going to be plus 36 over x plus 6 and x minus 2. And I'm not going to be able to factor out much from the top. I could, but again, you don't need to factor anything unless you think it'll cancel with something else. So I can just leave it like that. All right, next one. It's going to be 4x plus 8 minus 2x minus 2. So that's going to be 2x plus 6 over x plus 1 and x plus 2. 2x plus 6 factors a little bit. I could take out a factor of 2, but then x plus 3 would be left over, so nothing would cancel. Same story again. Let's see if we get anything more interesting on the next couple. Let's see if we can get something a little more interesting going on here. Ooh, yeah, definitely more interesting on number 21. There's some craziness going on in that denominator. Let's see if that factors at all. We'll factor a little bit to try to make it so that it's a little easier to deal with, maybe. And also, this fraction, everything divides by 5, I just noticed. And then here, everything divides by n. So actually, before we even try to add the fractions are easier when they have smaller denominators. Now, we don't know what n is. N could be a really big number, so it could make the fractions really, really big. But just in general, like big or complicated or whatever, there's just a lot going on in both of these fractions individually. Well, not that much in this one, but they both divide by n. So actually, I can do that. And that's probably what you want to do before you add or subtract. Now, I could have tried to look for that in these other ones, but, you know, like for instance, number 18, you know, if we look back at this one for a second, none of these numbers divide by anything else. B minus 8, B plus 3, those are all pretty simple terms to deal with, but when you look back at number 21 here, there's n's on both of those, so they have some common things going on. I can cancel out those n's, and on here I can cancel everything by 5. So that's a 1, that's a 1, that's a 1, that's a 7, that's an 8. If you divide everything by 5, that makes this a lot easier to deal with now. So if I rewrite it, what it looks like now, it would look like n plus 1 over n squared plus 7n minus 8 plus 7/3. That's a little bit less complicated, I think, yeah? And I think we can factor this bottom before we even try to combine those fractions. So if I try to factor out that bottom there, I would want two things that multiply to 8, 1 and 8. And they need to subtract to 7. So positive 8, negative 1. And now I can factor it. Ah, okay. So it does factor, but it doesn't factor into anything useful because we have n plus 1 on the top, not n minus 1. We have n plus 8, n minus 1 on the bottom. So it's not helpful. So we don't need to worry about it. We would just do the crisscross applesauce thing again. But at least we checked. It looked like it might have turned into that, but just wanted to check, but it's not going to turn into anything. So we don't really care. So we crisscross applesauce again, and that would be 3n plus 3 plus 7n squared plus 49n minus 56. All right, let me divide this out a little bit here. All right, all of that over, the new denominator, which would be 3 times, that quantity there. So let's go ahead and add this stuff up. We'd have 7n squared. That didn't combine with anything. We've got a 3n and a 49n, so that makes 52n. Okay. And then 3 and then 56, that's minus 53. Okie dokie. And then that probably isn't going to have any factors, so we don't have to worry too much about it. We can just write that as our answer. 7n squared plus 52n minus 53. And we don't have to refactor the denominator either. Remember, it does factor, but if it doesn't factor anything that's useful, then we don't have to worry about it. So that is our answer. Felt a sneeze coming on. There we go. Sometimes if you just pinch your nose, it goes away. All right, so 22. Crisscross applesauce. We have 9n minus 24 plus 6n minus 30. 9 and 6 make 15 minus 54. And both of those you can take out a 3, but it's not going to help because on the bottom we have n minus 5 and 3n minus 8. And that's it for that one. Okay. We did bleed over a little bit again, but I think we'll be able to have some extra space once we get to the bottom here. We were almost done, I think. 1, 2, 3, 4, 5, 6. Yeah, we only got 6 more here. It is starting to get more interesting now, that's for sure, because we've got some crazy looking fractions up ahead here. All right, let's skip over a little bit. Maybe go to yellow next, and then increase the thickness, because yellow is a little harder to see. Okay, so now what do you do when you have fractions on fractions? Well, what you could do is you could combine the fractions on the top and on the bottom. On the top, the fractions are already together. On the bottom, they're not, but you could put them together. That's one way to do it. However, another way to do it would be to just multiply by the LCM of all the denominators. So there's 1, 2, 3 denominators. 5 is already 25 is already a multiple of 5, I should say. So if you just take 25 times 4, that's 100. If I multiply everything by 100 on the top and on the bottom of the big fraction, that'll get rid of all the little fractions, and then I'll just have one fraction. All right, so watch. This is how that works. 100 divided by 4 is 25. 25 times 25 is 625. On the bottom, you'd have to distribute 100 times 1/5. 1/5 of 100 is 20. And then 100 over 25, 100 times 4/25, that's 100 over 25 is 4, times 4 is 16. So I would get 625 over 4, and that's as far as we can go, because 625 is 25 times 25. It's just a bunch of 5s. 625 is actually 5 to the 4th power. 5 times 5 times 5 times 5. So we're done. That's the answer. Not that bad, right? All right, on this one, the denominators are already ready to add up, so let's do it the other way. The way that you probably learned. The more common way to learn it, which is to combine the fractions and then do keep, change, flip. Or as I like to say, Kentucky Chicken Fried. So 4 plus 16 is 20 over 9. This is kind of a fraction, right? It's 8 or 8 over 1. You keep the 8. change divide to times, flip the other fraction. And 8 and 20 do simplify a little bit. They both go into 4. That goes in 5 times. That goes in 2 times. And then we multiply across. 2 times 9 is 18. 1 times 5 is 5. We have 18/5. All right. So let's switch to a gold. Actually, let's go straight to orange. And put the thickness back to a normal level here. About right there is fine. Okay. And over here, so again, you could do the same thing. You can combine them, or we can just multiply by 25. I actually like doing it this way better. I think it's normally always faster. So multiply both sides by 25. That would be a, because 25 times a over 25. And then 25 over 5 is 5 times a is 5a, so minus 5a over 25a. So this is going to be negative 4a over 25a. The a's cancel, and I just get negative 24/5. All right, next, multiply by 4 to get rid of the 4, and multiply by m to get rid of the m. Right. So that's what we multiply by. 4 over 4 cancels. I'd have 5m. 5m over here, the m's cancel, so I would have 5 times 4 is 20. And the m's cancel again right here. 4 times 4 is 16. 20 minus 16 is 4, so I'd get 5m over 4. And that's it. That's the answer. Okay, now the last 2 questions, and they are critical thinking questions. Challenge accepted. The first one is not so bad. It's just got a bunch of letters, got no numbers, but A, B, C, and D are all things we don't know the value of, so they don't have anything in common, so we crisscross applesauce. AD plus BC over BD. And that's actually it, because you don't know what anything is, so there's no simplifying, actually. The only simplifying was just putting them all together. And arguably, what we started with was more simple, because it's only got 4 things. A, B, C, and D only occur once each, whereas when you add the fractions, you actually end up with 1, 2, 3, 4, 5, 6 things, but that is probably what they'll want for an answer for number 27. But, you know, it is what it is. I mean, if you think about it, like, what does it mean to simplify, right? Like, simplifying means, like, to make it more simple. If it's more simple, you've got less stuff. So, actually, what we started with was more simple, I think. So, really, the question was the answer. Like, you had no work to do on number 27, in my opinion. But, again, what they're going to want for an answer is what I showed you just now in the box. So, just thought I'd give you my 2 cents. Speaking of giving you my 2 cents, if you like my 2 cents, you can go check out my 5 math mistakes everyone makes and how to avoid them guide on my website, Myers Mathematics. Go take a look and see if that's helpful. Number 28, last one. Split into a sum of 2 rational expressions with unlike denominators. Okay, this is actually very, very interesting. So the technical way to do this is what's called partial fraction decomposition. And that's what they're kind of wanting you to do on this one. So number 28, they really ramped it up really fast here. This is actually something that I didn't even learn until Calc 2. You're kind of supposed to learn it in pre-calc, but, you know, it is what it is. So when you factor the denominator, which we can, it would be x plus 2, x plus 1. Nothing cancels, but here's what partial fraction decomposition says. It says that if you can factor the denominator, and there's 2 or more factors, then you can split up the numerator, and you can split up the fraction into 2 fractions, basically. So that you have 2 things, and we'll call them A and B. And then the denominators would be x plus 2 and x plus 1. Well, if you think about it, like if it's this, what we would normally do is crisscross applesauce, right? So we would do like ax plus 1, bx plus b times x plus 2, all over x plus 2, x plus 1. So a times the quantity x plus 1 plus b times the quantity x plus 2 must equal 2x plus 3 if we're going to split this fraction up. That's the theory. It's partial fraction decomposition theory. Sounds really fancy. Kind of is, a little bit. But basically it just means that if you can factor the denominator, and it's got, multiple factors, multiple things being multiplied, then you should be able to split up your fraction like so, right? And it gets a little bit more complicated even than this, but I'm going to spare you because it's a little too soon. So basically, if we were to multiply this out, it would be a x plus 1 plus b x plus 2 all over, x plus 1, x plus 2. But this stuff right here is supposed to be equal to 2x plus 3, right? So now we have to figure out what a and b are, because once we figure out what a and b are, then we're done doing what they asked us to do. Split it up into two rational expressions with unlike denominators. So if we split it up a little bit here, let's see. So we could plug in whatever we want for x right now. That's the other thing that's a little weird, is like you're not thinking about that probably. You're like, what do I even do with this? You have extra letters. We wanted less letters. Less letters is better. And yes, so what we can actually do, we can actually plug in whatever we want for x. So here's what I'm going to do. I'm going to start splitting up the colors. We're going to use red, and we're going to say, okay, what if we make x equal to -1? What if we did that? What would that look like? Well, if we made x equal to -1, and I'm going to come over here actually, so I have some extra space. If we made x equal to -1, it would be a, and then x is -1 now, so it would be -1 plus 1 plus b, -1 plus 2 equals 2, -1 plus 3. And that looks kind of complicated, but the thing is, this cancels. And then this would just be b, because -1 plus 2 is 1, so that's b is equal to -2 plus 3, which is 1. So b is 1. We know what b is. b equals 1. b equals 1. Okay, not bad. That actually simplified pretty well. And if we want to do it again, we can do, let's do like a lighter yellowish orange on this one. So now, what if we do this? X equals -2. Okay, so then it would be a, -2 plus 1, plus b, -2 plus 2, equals 2 times -2 plus 3. Okay, this time, -2 plus 1 is -1, so this is negative a. But then the b cancels because -2 plus 2 is 0. 0 times anything is 0. And then we have -4 plus 3, right? So if we switch all the signs, because we want to solve for a, not negative a, then it'd be 4 minus 3, which is also 1. So a is 1 as well. A is 1. So they're both equal to 1. This doesn't always happen, but it does in this case here. So now we just rewrite it. Well, it turns out it was just 1 over x plus 2 plus 1 over x plus 1. Apparently that was it. That was all it took. So that is the answer. Da, 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 da. And if you guessed that, then you are a genius. Let me know if you're a genius in the comments below. But that is it for this video. If you liked it, like, subscribe, all that good stuff. But hey, go check out that thing on my website that I mentioned earlier, the 5 math mistakes everyone makes and how to avoid them. And I've got a bunch of other stuff on there too, like all of these worksheets. They're all saved on the website. If you don't see it, you don't find it, let me know. My email is in the description as well because I do private tutoring. So if you are looking for tutoring, you get your first hour lesson for free for any new student. So if you are looking into tutoring as well, you can go check that link out. It's not a link, it's my email. Shoot me an email and we'll talk. So anyways, that was the second half of adding and subtracting rational expressions. I'll see you guys in another video real soon.